Okay, hopefully you've had a chance to check out the review video for solving a system with 3 equations. We are going to take a little bit of a break from systems of equations and we're going to learn about matrices today. Okay, those are actually going to help us as we move into, we can combine systems of equations and matrices to help us solve those systems in a little bit of a different way. Okay, so the systems of equation is coming back. You guys will see that next week. But for right now, we're going to look at matrices. Okay, I don't think that you guys have seen this before. Maybe you have if you were homeschooled or went to a different school before coming to Hart, but I don't think you've seen it in a previous class. You might have seen a little bit in Algebra 2. So some of that will come back a little bit, but for the most part, this is probably going to be pretty new. So a matrix is a rectangular array of numbers written within brackets, usually named by capital letters. Okay, so this example here is matrix A. Okay, and it's read as A with a subscript of 2 times. Okay, but that times actually means 2 by 3. Okay, 2 by 3 because we notate it by rows. We have 2 rows and 3 columns. So every item listed in a matrix, so every number in a matrix, is identified by its position in the matrix. Each number, so lowercase now, mn, has 2 indexes. So your row index, so that's the location it is in a row, and your column index. So if we look here at this number, b with a subscript of 1, 1, that means the position of this number is in row 1, column 1. Okay, so any matrix will have a list of, or you can notate it by its specific position in the matrix. So a square matrix is any m by n matrix, so row by column matrix with the same number of rows as columns. Okay, it looks like a square, even numbers for your length and your width. Okay, so that should probably be pretty self-explanatory. Here's just some vocab words though with a matrix. We are actually going to do some algebraic operations with these. So first we're going to look at sum and difference, or adding and subtracting matrices. When you add and subtract them, they have to be the same size. So they have to be the same row and the same number of columns. You can't add and subtract them if their rows and columns are different. Okay, and then when you add and subtract them, you're adding the numbers that are in the same position for each of the matrices. So you're adding the number that's in row 1, column 1 for matrix A with the number that's in row 1, column 1 for matrix B. Same thing with subtraction. So here's some notation. We're actually going to do a few practice problems. Again, just like with any of these videos, you guys can pause this video and go back and write down some of the vocab words if you need to. It's up to you whatever notes that you think you're going to need. Definitely try the practice problems though, especially as this should be a little bit new for you guys. So here we have 2 matrices. We need to add and subtract them. So first thing I'm going to do is I'm just going to label the size of the matrix. So matrix A, I have 3 rows. Okay, rows go across, columns go up and down. So I have a 3 by 3. Notice it's a square matrix, looks like a square, pretty even on both sides. Rows and columns are the same. And matrix B is also a 3 by 3. That's just a way for me to double check that I can actually add and subtract these matrices together. All right, so for my new matrix, this is going to be matrix of A plus B. I am adding the numbers that are in the same position together. So I'm adding 2 and 5 together. That gives me 7. Notice that that 7 is going in the same position that the 2 and 5 are in matrix A and B. Okay, I'm going to go across the row first. So then I'm adding 4 and negative 2. So that gives me a positive 2. I'm adding negative 3 and 0. Gives me a negative 3. All right, we're just going to go down to the second row now and add those numbers again. Negative 1 and 4 gives me a 3. 0 and 6 is a positive 6. 1 and 9 is 10. 3 and negative 5 is negative 2. 2 and 1 is 3. Negative 2 and negative 2 is a negative 4. Okay, so that should have been pretty easy for you guys to solve. Now we're going to look at a minus b. So same thing that we just did, except now you're subtracting numbers. The key thing with this is to pay attention to negative signs. If you are subtracting a negative number, you're actually going to add that number, so it'll become positive. Okay, so 2 minus 5, negative 3. 4 minus a negative 2. Okay, I'm just going to write that here, minus a negative 2. That actually means that you are adding 2. So that is going to become 6 for that middle term on your top row. Negative 3 minus 0 is negative 3. Okay, go ahead and try to see if you can fill in the rest. You guys should be able to do this. Shouldn't be too challenging. Okay, that should have been your answer then for a minus b. Notice that for this last one, you have a negative 2 minus a negative 2, so that's just going to equal 0. All right, adding and subtracting should be fairly easy right now. Here are some more operations with that. You can do adding and subtracting, which we just did. But just like with any normal rules with algebra, you can have those same types of rules with matrices as well. So cumulative property, if you add a and b together, or if you add b then a together, you're going to end up with the same thing. Okay? Associative property, let's say we had 3 matrices that we're adding together. It doesn't matter if I if I add the first 2 together, or if I add the last 2 together first, before adding them all up. You'll still get the same answer. 0 matrix. Okay, if you're adding a matrix of 0, that means you're adding nothing to every single term, so it's just going to stay the original matrix value. And then scalar multiplication, this is like your distributive property. That k is just representing a number. Okay, so you would multiply that number to each matrix. So for example, let's just do one right here. If I had 2 times matrix A, that means I'm multiplying matrix A by 2. So that means my new answer is going to be 6, 8, 2, 10. And then I'm going to add that to a separate matrix of 2 times B. Okay, so every single number gets multiplied by 2 in that matrix. Okay, again, adding and subtracting matrices have to be the exact same size. All right, so if you guys want to go ahead and try these on your own, you can pause the video here, try them on your own, check your work. I'm going to quickly kind of walk us through what this is going to look like. First thing I'm going to do for problem A, first thing I'm going to do is list the size of the matrix. So 2 times 3, 2 rows, 3 columns. And this one here is a 2 by 2 matrix. All right, so first thing for problem A is I'm going to multiply every number in A by 2. Okay, so my new A matrix will be 10, 2, 0, 6, negative 4. Then my new B matrix is I am going to multiply everything by 3. Okay, there's a couple ways you could have done this. I multiplied by everything in matrix B by 3. What you could have also done is multiplied everything by that negative 3. And then your next operation, instead of subtracting them, you would just go ahead and add them together. Okay, so that's up to you how you wanted to do that. A couple different ways that we could have done that. All right, so now that we have multiplied all these numbers by the matrices, we're going to go ahead and subtract them. Okay, pay attention when you're subtracting that new B matrix. If you're subtracting a negative number, you're actually adding that together. So I have 10, negative 4, negative 6, 21, negative 3, and negative 28. All right, pretty simple for that one. For C, we are for problem B, we're multiplying matrix C by 1/4. So what you're doing, multiplying by 1/4, is the same as dividing everything by 4. So your new matrix is 12 times 1/4, or 12 divided by 4 is 3, 0, -1, and 2. And that's it.